Hello, and welcome to Learning Science by Being a Scientist. In this video, we are going to explore how and why scientists analyze and interpret data. If you are going to be a scientist, you need to know about data. Data is the lifeblood of science, where we get it, what we do with it, how we use it, what it all means. It's all about data. Remember when we said that science is about questions? And we said that in order to get the information you need to answer those questions, you need to do investigations? Well, that information is called data. So, what is data? Data is the information a scientist collects during an investigation or experiment. It is what the scientist needs in order to construct an answer to their question. Data comes in many forms. When you, as a scientist, measure something, distance, temperature, time, mass, weight, volume, those numbers are all data. When you, as a scientist, count something, the number of flowers that grew on a plant, the number of fish that have a certain color, the number of rocks that are a certain size, those numbers are also data. Anytime your data is in the form of numbers, it is called quantitative data. Quantitative means that the data comes in the form of a quantity or number. But numbers aren't the only things that can make up data. Observations can also be data. Information you get from your senses, what you see, hear, smell, touch, or taste. These are observations you cannot easily measure or describe using numbers, but they are just as important. When you, as a scientist, use words to describe the things you observe with your senses, the appearance of the moon in the night sky, the texture of a dying plant leaf, the smell of an eggshell after soaking it in vinegar, the flavor of a giant donut, how one sound from a cello is different from another. All of these descriptions are observational data. Anytime your data is a description of what you observe, it is called qualitative data. Qualitative means the data comes in the form of a description and is summarized using words. So now that you have your data from your investigations, what do you do with it? Data needs to be organized. To do this, scientists use charts. A chart lets the scientists line up all their measurements, numbers, and observations in a way that makes sense. Scientists can then take their numbers and create graphs that show a picture of what the data looks like. Bar graphs compare different groups. Pie graphs show all of the parts of something as a percentage of the whole. Line graphs show how something changes, usually over time. The thing about graphs is that in order to make a graph, you need to have numbers. And if your data is qualitative, that is observations, you have words, but no numbers. Good news is that you can turn it into numbers by counting the number of times you observed something, or by creating a rating score for how something looked, sounded, tasted, etc. And once you have represented your data in a graph, you can look for all sorts of things. You can look for patterns in the data. You can look for trends in the data. Scientists use their data as evidence to construct explanations for how and why things happen. An example of an explanation would be, fertilizer brand B is the best for growing lots of flowers because of the different nutrients it has in it. It is your data, counting of the flowers, along with knowing what nutrients are a brand B, that lets scientists say that. In order to use your data to construct an explanation for how or why something happens, you also need to connect your evidence to the science concepts that explain why you got the results you got. Why did you grow the most flowers with brand B? That's what your data said. Because it has the best combination of nutrients to help the flowers grow. That is the reasoning with scientific concepts. So there you have it. Data is what scientists use to construct the answer to their question. Data is the evidence that helps the scientists show why they think their answer is the right one. And if they did their investigation right, anyone else who does the same investigation should get very similar data. Without data, their answer is just a guess with nothing to back it up. Thanks for watching. Come back soon to watch more videos about what scientists do. And remember, the best way to learn science is to be a scientist, and that means doing what scientists do.